Welcome. So, we will talk about satellite communication systems. This is a wireless communication which covers very large area. So, today is the introduction. We will try to see why do you need it in such a difficult type of communication, and then we will go back to history. Most of the textbook they talk about history of US satellite communication. I will also cover what is happening in India, what happened in India, and then we will try to see what it is, what we are going to cover in subsequent lectures, and a few terms in this process you will learn, and maybe a few units also you will learn. Let us start. There is a need of space communication. What is the need? It is a wireless communication. Terrestrial microwave links are not suitable to meet a cover large geographical area, particularly for radio, television networking, even cellular telephony, large geographical area. The basic requirement is Earth is not flat, Earth's surface is not flat, and microwave communication, it goes straight line just like light. So, therefore, if there are two towers, the second tower, unless it is in the radio visibility, it will not be able to receive the signal from the transmitting tower. So, therefore, only a short distance can be covered, and you can see that our mobile towers can cover a smaller distance. Radio and television earlier days, the large towers, some of you might have seen in big cities, they cover only the city. So, therefore, let us do a very small interesting calculation. This is just for fun. How many cellular towers are required to cover Indian landmass? Let us take very simple type of numbers. Let us say Indian land area is about 4 million square kilometer, and a mobile tower can cover with a radius of 1 kilometer for simplicity, and let all the mobile towers are interconnected to provide a all India coverage, a true all India coverage. Any geographical place in Indian landmass is covered. Let us take this problem. We have to calculate the number of mobile towers required for it to fully cover India. A mobile tower coverage can be calculated pi r square, 1 kilometer radius. So, it is 3.14 kilometer square, and our Indian land area is given as 4 million square kilometer. Divide by that number and you will get a fantastic number. 1.27 million towers are required, almost like impossible. This is just fun calculation. Let us see. Normally these towers are less than 100 meter, which covers a small part of a city, a town. Now, if we really want to cover a larger and larger area, we have to increase the height of the tower, and it can be seen that a very long height can cover 1/3 of the earth, and these top of the tower we can put a repeater. Now, I am first time using a word which is repeater, which receives the microwave signal and transmits it back. So, more earth coverage is possible at a higher altitude, and that higher altitude, it is roughly calculated as 36,000 kilometers from the surface of the earth. We will do all the calculation later. Today just we are giving some numbers. Now, such a impossible height of a tower cannot be realized with today's technology. So, what we do? We should float the repeater. We should float the repeater by the name called communications satellite, and that will be floating, means it will be orbiting around the earth. So, we should learn about how it can orbit around the earth instead of simply floating, and that will be at 36,000 kilometer above the earth's surface. So, this repeater with its radio visibility will permit 2 or more users, any number of users that is available within its radio visibility, to deliver and exchange the information in various forms. Let us go back to the earlier idea. Around World War II time, 1945, wireless world, Arthur Clarke, a scientist, later he became a novelist, he wrote a seminal paper, did some calculation, and he did not use the word satellite. He said a microwave repeater, if it can be floated, then 3 such satellites can cover all the earth, and this particular height he calculated and said it is called geosynchronous orbit. We will learn more about it later. Let us see, India has some satellites, it is called INSAT, Indian National Satellite. From the satellite, this is a real picture. If it looks at earth, it looks like this over India, and this satellite is placed over above the equator, a full earth view. So, anybody, any place from this visibility can see the satellite, radio visibility, radio seeing, and satellite also can see by the radio. Now, if this field of visibility is reduced to Indian land mass, then within that circle, what I have put as a yellow circle, within that circle the radio visibility is there from the satellite. So, any user can transmit a signal with the radio visibility of the satellite, and within that radio visibility others can receive it. A satellite is nothing but a repeater, it is a smaller field of view. Why it is necessary? Because the larger field of view you can see the most of the part is ocean. So, if there is no requirement of the communication with the some person in ocean, there may be some small requirement later we will find, but most of the customers or users are within the land mass, and if we specifically use it for India, so we should cover India. That is a smaller field of view of INSAT, and that is communication is possible only within the radio visibility of these stations which are in the radio visibility of the satellite. It is a very simple way of telling it. Now, let us see the advantages of this type of communication. The basic advantage, it can broadcast to a very large area, it is cost effective, it can reach to a large number of customers with one single repeater. You can remember the example of the tower what we said earlier, large number of towers were required, now it is only one tower and it is a virtual tower. There is one more thing you can see, that communication is reaching to the unreachable area. By unreachable I try to mention that most of you are using mobile phones, cellular telephony. Many places when you travel, when you are on highway or railway or some cities, towns, you are getting connection, but many other places if you go across smaller villages, across the fields, over the rivers, when you go, you do not get the connection. So, these are all unreachable area. There also the satellite signal is reaching, we have seen just like the view what we showed just now. Then it is another thing that is a reliable solution to the last mile problem. This is a very interesting thing. Last mile problem is from the last exchange to your place where your computer is there or telephone is there, that is called last mile. That junction problem is a serious problem, and with satellite directly, since you are not using any local wire or no local small transmission where multipath and other effects are coming, and satellite is vertically above you, this last mile problem is much less. Now, let us see that last mile problem, if you go by where telephone people, fiber optics people, they need to dig the roads. You don't need to dig the road because you are looking at the sky. It is easy and quick to set up, and based on what is the requirement of the bandwidth or power, you can quickly set up, and in case of wire communication that is slightly difficult. Most of the use is in case of disaster, when all other communication fails, then this satellite communication remains. Of course, it is required for the defense, is unreachable area when you reach, then by satellite communication it is possible. It provides the fairness of service as demanded, like diverse user network, whether you are using television communication, whether you are using video conferencing or simple telephone or much simpler data exchange, mails. It can be used for different bandwidths on demand. And then it has a long life. This repeater is above atmosphere, no disturbance, atmospheric disturbance, ionospheric disturbance. It's much high above, so its life is much larger, so you don't have to maintain there. So therefore, it is very cost effective. These are a couple of advantages. And let us go back to the early experiments. People have tried many things to reach this type of technology, to achieve this type of technology. Initially people said that why not use moon as a reflecting surface for the radio waves. It was tried out for some time, but moon is always not visible. Some times of the day moon is not visible. So therefore, communication is quite difficult, continuous communication, and also you need large power to transmit signal, go to moon and it should come back. So high power is required. People used copper needles in the sky, and the copper needles were floating, means actually orbiting, and reflecting surface was created. But that also becomes very erroneous and bursty in nature. So therefore, it was not effective. People tried balloon, copper coated balloon. It was tried, the balloon name was Eco 1 and Eco 2. Two such balloons were launched, and that also was tried, not very effective. The disadvantage is very high power is required to transmit from the ground, then large astration, you have to track the facility from where it is to be signal is to be reflected. Then via moon is of course is not very comfortable, because moon is not available always, and the global system will require large number of passive satellites if you use small eco type of satellites, and control of the satellite is not possible because it is passive. Therefore, people started thinking of active satellite. It has certain basic advantage, like it requires lower power earth station because the repeater is there, it has amplifier on board, and it is less expensive than the passive system. It is not open for random use, no random transmissions going, and it can be controlled, that who is transmitting, who should receive. It can be directly controlled by the operators from the ground, and it has also certain disadvantages, like you need high reliable design, because in case of electronic component it fails on board, then the whole system fails. It is a single point failure. So therefore, it has to be high reliable design. We will talk about the reliability much later. And then onboard power supply is required. So you need a battery or you need solar power. We will talk about this later. And then it needs heavier rocket to launch such a heavy mass. So therefore, launching cost is quite high. Even with that, first commercial satellite, which is called Intelsat 1, was launched in 1965. It has a mass of only nearly 40 kg, about 1.5 year lifetime. It could broadcast one analog TV channel, and the transmit RF power was 7 dBW RF power. Mark dBW. This is a power unit in dB. When you convert into direct ratio power, it is equal to 5 watts. This dB unit has to be learnt quickly, because we will be using it very frequently later. So it was having only 5 watt RF power, and corresponding ground station in India, which was set up in 1971, has an antenna of diameter of 28 meters. So you can see such a large, huge antenna was required on the ground, and the ground power requirement was 3 kilowatt. There is a low noise amplifier, we will learn about it later. The noise of the amplifier has to be controlled by reducing the temperature, and that was kept at 50 degree Kelvin. That is also another difficult situation. And much later, the Intelsat 10th generation, the version 2, 1002, was launched in 2004. You can see it is 5.5 ton almost. It has steerable spot beams and many transponder, a new terminology again, transponder, which is some form of a repeater. We will talk about it later. There are 36 of them in Ku band and 70 of them in C band. These bands also are new terminology. We will learn about it later. Similarly, over the sea, Inmarsat is there, so which is launched in 2005. This is Inmarsat 4. It is a 6-ton 12 kilowatt satellite. It has a solar array of 48 meter. It is 67 spot beams. These are all taken from internet. Similarly, another one is the IP Star. Right now it is existing. It has so many colored spot beams you can see. Over India also it is there. It provides service in Ka and Ku band, and 2005 it was launched. It is also 6.4 kg satellite. You can see these are huge satellites, and corresponding ground station now it is reduced to 0.8 meter, 1 watt, 2 megabits per second. Thuraiya is another satellite. Mobile phones can be used. Just the cellular phone what you use, same thing can be used with Thuraiya satellite. It's Arabian satellite. Similarly, Japanese have launched another satellite for testing. This is, you can see, 40 meter antenna diameter, 40 meter span of solar panel, huge, 5.8 ton at launch. So such big technologies are there. Even much lower Earth orbit, it's called LEO. 66 satellites constellation was launched by Iridium Consortium, and each satellite has 48 spot beam. Anywhere in the world you can communicate via this satellite. India, we had a development phase in 1975-76. We tried with a borrowed satellite from NASA, and that was tried with a small parabolic dish of 12 feet diameter, approximately 10,000 rupees, and it was for school development in the villages. And you can see that it was tried just like a DTH, direct to home, in 1970s. Another evaluation phase we went through, we borrowing a satellite Symphony from Europe. That was for post and telegraph. It has a transportable station. We communicated. The picture is there. It is a satellite news gathering terminal. So those days in 1970s, we have tried many evaluation, and later we launched our own satellite called Apple, and that was the first commercial, first ComSat payload, communication satellite payload. A lot of experimentation was done, and subsequently we launched Indian national satellites. And 2008 we had almost 211 transponder and many such satellites at different places in the orbit scene, and almost now similar number of satellites are there. Now, satellite communication can be used for direct to home broadcasting, for television, radio, satellite news gathering, very small aperture terminal, internet service provider, mobile network backbone, television radio networking, disaster communication, mobile communication, remote area communication, a lot of things. Normally these are the bands where you can see the yellow color top microwave. That band is used for satellite communication, and you can see in this table frequency bands which are available. Towards the bottom, 30 gigahertz, 3 gigahertz to 30 gigahertz is super high frequency satellite. Microwave is covered in that. There is the International Telecommunication Union which standardizes this natural resource of wireless communication. They have divided the world into region 1, 2, 3, and India falls in region 3, and they provide a table. That table, one page I have shown here, where the bands are shown. You can see region 3 bands where you can see fixed satellite service, space to earth, similarly fixed satellite service, mobile service, broadcasting satellite service. Different bands are given which are allowed for communication for space to earth or earth to space. For one way it can be used, there is a big list I have provided, which is for broadcast satellite service, data collection service, space taking operation service, etc. Similarly, two way it can be used for fixed satellite service, mobile satellite service, news gathering service. So these terms what I am using are listed by ITU nomenclature, called fixed satellite service FSS, broadcast satellite service BSS, mobile satellite service MSS. Like that, there is a big list of that. So these are the terminologies we will be using frequently. And the bands, in very common general term, it is used for satellite communication is L band, it is 1 to 2 gigahertz, S band 2 to 4 gigahertz, C band 4 to 8 gigahertz. Particularly what we see in our regular daily life is direct to home television, cable TV, as well as the VSAT communication, which is in Ku band 12.5 to 18 gigahertz, that is for FSS fixed satellite service and broadcast satellite service. BSS is also allowed in K band, which is 18 to 26 gigahertz, and Ka band is for fixed satellite service 26.5 to 40 gigahertz. These are roughly these are the bands, but the details are shown like the previous page I have shown. There is a radio regulation. Now, main components of satellite communication is a space segment, which is the satellite, as well as controlling part of the satellite. There is a satellite control center. Space segment consists of nothing but a receiver, amplifier, and transmitter. That's all. It's a repeater. And there will be ground segment, which will be communicating to this transceiver on the satellite, a transmitter station, a receive station. The station, though I have shown here pictorially sketch a large station, it could be very small station also. And coming in between medium, which is the propagation medium through which the signal will pass. So, we will learn about how to put the satellite into that space, then what should be there inside the space segment, what is there in the propagation media, and what is there in the ground segment. So, our topics subsequently will be, we will learn about orbit, where the orbital dynamics of the satellite, the velocity, the orbital height, how it can be calculated, how it can be placed in the orbit. We will learn about it in subsequent couple of classes. Then we will talk about the space segment inside the satellite, what is there, and then we will talk about the other things like ground segment, propagation effect. The link budget is very important. I may advance the link budget a little early, and link budget is how much power you should transmit from the satellite as well as from the ground based on your signal to noise criteria. And since it is covering very large area, we will talk about multiple access, multiple users can access the satellite, and there are certain technical issues that we will discuss, which is about the nonlinearity, about the synchronization, about the effect from this physical layer to the higher layer, that is data link layer and the transport layer, network layer. So, that also we will discuss. We will discuss about the regulation and certain standards. Now, what we learned till now is the SATCOM is a form of wireless communication which covers a large geographical area. Also, we learned that these communication satellites generally are used in the microwave band, and it can be called as a microwave repeater. We have seen a very briefly early history of SATCOM internationally and in India, and certain technical terms like BSS, MSS, FSS and DTH, DB, DBW, these are the certain terms we have used, and we have seen what is the international frequency band that is used for these services, and some technical units like dBW and gigahertz. These are certain things we have used. Now, I will leave certain questions for you to go through this video and try to answer yourself. I will not give the answer, you can see the answer in the video itself. In which year the first international commercial satellite Intelsat 1 was launched? How much was the RF output power in watts of that satellite? Remember, I am asking in watts how much it is, and what are the frequency bands for broadcast satellite service BSS. You go through this video and try to answer it yourself, right. Thank you very much for today, and next class onward we will start about the technical issues about the orbits and how the satellites behave in the orbit, what is the effect of the orbit for our communication purpose, and then we will go into the space segment and link budget. Thank you very much.